On October 9th, 2009, the LCROSS mission impacted a permanently shadowed region in the lunar south polar crater Cabeus. And the purpose of the mission was to excavate part of a crater that receives no direct sunlight throughout the year, and for that reason is extremely cold. The part of Cabeus crater where the LCROSS mission impacted had an average temperature throughout the year of about 40 degrees above absolute zero. So at those temperatures, volatiles like water ice are extremely efficiently cold trapped, and they behave more like rocks than what you would think of typically as water. So Diviner had a unique opportunity to observe the impact and determine the temperature behavior, which tells us something about the properties of the impact site. So we wanted to know how fast the impact zone heated up and cooled off, what the peak temperature was, and what that cooling trend tells us about the physical properties of the impact site. And we also wanted to know how the volatiles like water would behave during that process. So the spacecraft orbit was adjusted to bring LRO around at closest approach to the LCROSS impact site in Cabeus crater about 90 seconds after impact. So we targeted the impact site with Diviner on the orbit 90 seconds after impact, and then on each subsequent orbit. The orbits are separated by about 2 hours each. And as it turned out, we recorded the emission from the impact site in Cabeus crater in all 7 of Diviner's infrared channels as a bright pinprick of light on the dark floor of Cabeus crater. During the course of the descent of the LCROSS shepherding spacecraft, which was following behind the Centaur upper stage, which impacted the surface, the LCROSS shepherding spacecraft observed a continuous flux of water molecules, of water vapor coming off the surface. And based on the Diviner temperature measurements, we found that this flux of water could have been due to the heat of the impact slowly conducting downward into the cold subsurface and vaporizing water molecules gradually from the subsurface regolith. So Diviner's measurements of the temperature provide a constraint on the rate of water vapor produced in the steaming crater. One of the most surprising observations that Diviner made of the LCROSS impact event was that the solar channels, which measure light in the visible part of the spectrum, saw a twinkling around the impact site in Cabeus crater. And these channels normally don't see anything in these dark regions where the sun never shines, but we saw this twinkling that only happened on the orbit 90 seconds after impact and then went away. And it turns out this is due to scattered light reflecting off of grains that have been ejected by the impact of the Centaur into the floor of Cabeus and brought up into sunlight. And using the intensity of the light that was scattered off of those grains, we were able to determine the mass of ejecta particles brought up into sunlight. And this is important because it provided an independent check on the amount of material that LCROSS was observing at the same time, which is used to determine the abundance of water ice in the lunar regolith.